So a question that comes up a lot is, when should I pump my basement? If the house has a basement. And when a situation is like this, and there is that much water that it's covering the basement walls, that's when you don't pump the basement. Because if you get the basement empty of water, there's going to be so much hydrostatic pressure it'll push the basement walls in. So you wait until the land is dry. If you have been forced to leave your house for a while, be careful when you go back in. You've been displaced. A lot of wild animals have been too. I've seen different recommendations for going back in. Take a dog with you. Take a weapon, just to make sure you're not surprised by something. And then if there is standing water in the home, turn off the power or have it turned off by an electrician, and do that from a dry location. Don't turn the power off or use any electric tools while you're standing in water. Depending on how bad flooding has been, you have to think about the electrical system, that could have been damaged and could lead to dangerous situations. So you might want to have that inspected, and some components might have to be replaced. In this case, it's a damaged receptacle.
Hey Joe.
Yes.
Because I never even thought of that, just from my own future perspective, that it almost seems like, is there any way you can cover your receptacles before you leave the house? Is there any way to protect that?
Not that I can think of. You've got those little plastic inserts that go in the slots, but that's not going to do much. No, and then once water rises, I don't know.
It just messes with you. Okay, all right.
So what is mold? Mold is, they're fungal colonies, and they produce woolly, fuzzy growth on paper, hard surfaces, spoiled foods. Mold loves cellulose, so mold will grow on paper, cardboard, wood. You always hear mold and mildew, mold and mildew. What is the difference? Does anybody know? No, they're both fungal colonies, but we call it mold when it's on a hard surface, and we call it mildew when it's on a fabric or shoes.
Kidding.
Yeah.
Okay.
Is mold always negative? Well, most news stories we hear the bad things about mold. It can permanently rot wooden structures, and exposure to high levels can make anybody sick. Even if you don't have asthma or allergies, if you get exposed to a lot of mold at one time, you can develop allergies to it. So there are some benefits for humans. We've got bread and beer because of mold. Fungi is widespread in the environment. It comprises 25% of the Earth's biomass. It's one of the few organisms that can break down wood and wood-based materials into simple, digestible compounds. And houses have plenty of food for mold. Most homes are made of wood, and then the houses are full of wood-based furniture, cabinets, books, paper-based products. But these are these factors necessary for mold growth. And be aware that mold spores are everywhere. If you took an air sample from this room and looked at it under a microscope, you would see mold spores. But mold spores aren't going to grow until they have the right temperature, food, and most significantly, a source of moisture. And once food materials, and remember for mold, food materials can be wood, like a 2x4, 2x6. It has to be 70 to 80% saturated. And then it'll be accessible as food for mold. So byproducts are produced by mold. And that's from breaking down the food sources into usable nutrients. So these are the byproducts of mold: carbon dioxide, water, and volatile organic compounds. So they're, or VOCs. And we call them volatile organic compounds. Volatile means that they can spread as a gas at room temperature, organic or carbon-based. And then there are mycotoxins. So some fungal species also produce secondary materials. These are mycotoxins. There are some good mycotoxins. They protect. The theory is that molds produce mycotoxins to protect their food source from other types of mold. Penicillin is a mycotoxin. It's very toxic to bacteria, as we know how it's used in medicine. But some mycotoxins are toxic to mammals. And a good example of that is aflatoxin. And that's what grows on spoiled foods, especially grain and peanuts. And these are much more potent than some industrial chemical compounds. Trichothecene is also produced by mold, and that's toxic to humans. So when you go into a house that's been contaminated by mold and you smell that musty smell, that's the volatile organic compounds and the mycotoxins. So your nose is a pretty good indicator to whether you have mold or not. You don't always have to have the house tested for mold. If you can smell, it's there. Some other misconceptions about mold. While I was working, I would get a call at least once a year that I've got black mold or green mold. Do I need to get out of the house? And that happened because in 1995 there was a big flood in Cleveland. And a dozen or so infants died. They were bleeding from their lungs. That's what killed them. And the Centers for Disease Control and Prevention did an investigation, and their initial conclusion was that these infants were exposed to toxic mold. Specifically, it was Stachybotrys. Much later, the CDC tried to retract that statement that there are toxic molds, because there's no such thing. Even the members that I told you I was on the task force for toxic mold, most of us didn't like the name of that task force. Mold isn't toxic itself, but it's toxigenic. It produces toxic compounds. So it doesn't matter whether it's black or green or white. Just remember, mold is mold. Some molds don't have pigment. And a good mold mitigator will actually, when he or she is doing an inspection of a house, will take a flashlight and shine it across a wall. And you might see a shadow. You can't see the mold because it doesn't have any pigment, but the shadow indicates something's there. So fungi produce massive amounts of spores. And spores are to mold and fungi what seeds are to plants. And they are released from the fungus and they drift in the air all the time. Then they'll eventually fall on a surface. And if the temperature's right, and if that's a surface that can be used for food, like wood, and there's enough moisture, then the mold is going to start to decompose it. So here are some mold spores. I was at a workshop years ago when this New York State used to have a mycologist. Those are professionals who study mold. And he showed us, he was a real mold geek. He would go to mold camp every summer. He and his colleagues had a lot of fun. They would take samples from the air and then pull out their microscopes and look at it and then have contests identifying that. Here you can see a spore that is developing, getting ready to grow. So once mold is on a surface that's favorable to it, it starts growing hyphae. Hyphae are tube-like structures that contain nutrients. The hyphae continue to spread out. They get to a point where you can see on the bottom slide, on the bottom picture on the right, where it's then called mycelium. And that is a massive section, or massive growth of hyphae. And then the hyphae start digesting, let's say wood, that it's on a wood surface. Starts digesting that. It breaks the hydrocarbons in wood down to easily digestible sugars. And that's what the mold lives on. And here it's giving off volatile organic compounds, water, carbon dioxide. I forgot what the TN is. But
I was going to ask you what that was.
I'd have to think about that. It could be in the sheet that's up there as a handout. That's where I got this picture. So this is what happens. A lot of people are not affected by mold, but people with allergies and asthma are. In fact, mold is an asthma trigger, and if an asthmatic is exposed to enough of it, can start having an asthma attack. You can get fungal infections on your skin, inside you, or an illness which is called mycotoxicosis, all from exposure to mold. So if you have mold in your house, can you clean it up yourself? The general guideline is if you have 10 square feet or less, yes, you can clean it up yourself. You should protect yourself with a respirator. And the thing to look for when you buy a respirator is N as in number 95. That's what's recommended by the EPA when you work inside an environment that's contaminated. They're not that expensive. You can get the more expensive ones that strap on your face and have the removable cartridges. I keep one of those in my house. But the N95 respirators are okay. Now, when you get...
Excuse me, Jim,
Yeah.
could you repeat that again? N95?
N95 respirator, yeah. That's the one to look for. And they're inexpensive.
What was the name of that respiratory
Mycotoxicosis. So when you get up to around 100 square feet, trained building managers can do it, or professional mold remediation contractors. And now mold mitigation or remediation contractors have to be licensed. When I wrote that fact sheet that is over there, hiring a mold mitigation contractor, I think that was in 2005. Anyone could be a mold mitigation contractor in New York State. I told you I was on that task force for toxic mold. There were 14 of us, and at the time about half the states required mold mitigation contractors to be licensed, but New York wasn't one of them. And so the three of us on that task force were recommending that, well, in our report to the governor and the legislature, we should recommend that mold mitigation contractors be licensed in New York State. But that didn't get through. We had one representative from the state health department, and she said, we just don't have the money to police this. And the governor at the time had put a freeze on any more state positions. So our hands were tied, and even if we'd recommended it, it would not have happened. Then Hurricane Sandy came along in New York City, and some people calling themselves mold mitigation contractors really had no training in that. There's a misconception that all you have to do is go down there with some bleach and scrub it up. That's not the case at all. It's a very dangerous situation when you have a big contamination. People need special training. So that fact sheet, I'll walk you through that fact sheet, but it doesn't mention licensing. But if you hire a professional, ask to see his or her license. So people say, well, do I have to sample? Do I have to know what kind of mold I'm dealing with? No, it's usually not necessary. If there's a court case where someone's being sued, that's usually when they will want to identify what type of mold it is. But it's not necessary.
Joe, this is the one you're...
Yes.
This one.
Thanks, Beth. So a thorough visual inspection, that's what's generally appropriate for deciding what to do, how you're going to clean up the house. But we don't have standards or widely accepted guidelines. Part of the legislation that created this task force I was on said that what they wanted to see was a threshold of exposure to mold beyond which it's unsafe for humans. And that just doesn't exist with mold because everyone reacts to it differently, especially if you have allergies or asthma. Is that okay? So here's the N95 respirator I mentioned. And if you're cleaning up a mess that's less than 10 square feet, wear the respirator, gloves, and goggles. And you don't want to get anything in your eyes. So here are some recommendations. if what you're cleaning up are books and papers, let it dry out, and then use a HEPA vacuum. HEPA stands for High Efficiency Particulate Air. When HEPA vacuums first came out, they were really expensive. I think it was about 15 or 20 years ago. But now most of the vacuum cleaners you get have HEPA filters, or they're HEPA units. You can't just put a HEPA filter into a regular vacuum cleaner and expect it to act like a HEPA vacuum cleaner, because dust gets thrown out of and gets sucked into all parts of regular cheap vacuum cleaners. And then carpet and carpet backing, if you can save it. And if you've got carpeting that is really infested, in this case it would be mildew, wouldn't it? Because it's fabric. So remember that. If that's really infested, you're not going to be able to clean it. Yeah, throw it on. But if it's just a light infestation, you might be able to take care of it with steam cleaning and then a HEPA vacuum after it's dried out. Concrete or cinder block, yeah, you can wet vacuum, HEPA vacuum again. Then hard surfaces, you can damp wipe that down with detergent. There's a misconception that you have to use bleach to kill mold. That's not the case. Just regular cheap dishwashing detergent will work. You can use bleach if you want to. That'll kill it, but soap will kill it too. And then non-porous surfaces like plastics and metals, these are the easiest to clean. Damp wipe the surfaces with detergent. Wet vacuum, steam clean. You can use a HEPA vacuum after they're dry. Upholstered furniture and drapes. It's unlikely that you'll be able to save them, but you could try that with wet vacuum or steam clean. Wallboard, or what we call drywall or gypsum. Usually you're not going to be able to save that, but if it's just a mild infestation, again, a HEPA vacuum. Wood surfaces, damp wipe the surfaces with detergent, wet vacuum, steam clean, and then HEPA vacuum after they're dry. Yes?
I saw where Home Depot sells products and they say all you have to do is spray it on and leave it. You don't think that's good? Or,
I don't know what the product is. Is it an encapsulator, like an epoxy coating?
No, it's just in a spray gun.
I would want to get rid of it. It doesn't look good. Doesn't seem healthy to leave it there. I'll go to Home Depot and look at that. Oops, I'm not supposed to mention
Well,
that.
like you're like underneath a sink, for instance. It says you can wipe it if you want, but you can just spray it and leave it.
Yeah, I'll look that up. I'm not familiar with that product. Thank you for bringing that to my attention now.
That's a really good thing though then. Then if it were to dry, and I'm wondering, Joe, then could they vacuum it and you need a smaller, handheld thing to suck it up? It seems to be based on your recommendation.
Yeah, HEPA vacuum cleaner.
HEPA after that.
You know what comes to my mind? I use one of these CPAPs for breathing problems.
For sleep apnea.
And I clean it with white vinegar and water. And I would be a bit surprised if what you're spraying under the sink or what have you is just simply white vinegar and water.
Yeah, look at the ingredients. A friend of mine was going to clean his deck, and I went to the big box store with him and watched as he was pulling out deck cleaner. I said, "You don't need to buy this, John." And you look at the ingredients: sodium hypochlorite, which is bleach.
What's that product called?
I don't remember.
And if anybody wants to try it, it's 25% white vinegar to 75% water.
Okay, thank you. So, after Hurricane Katrina, a friend of mine in Washington, a wealthy friend, his name's Curtis T. Bell, wanted to make a donation to do something about Katrina. And I think there were some special tax advantages that year too. And so I put into one of my Cornell accounts enough money to develop this fact sheet. I wrote it with Claudette Reichel, she's a professor at Louisiana State. She was up to her eyeballs working with mold after Katrina, and so she and I wrote this together. At the time, yes, that's that one.
Does everyone have that?
Not yet.
At the time, mold mitigation contractors had to be licensed in Louisiana, but not New York State. But even though they have to be licensed, and if you hire a licensed contractor to do this, you'll be better off if you are informed. And what this fact sheet does is it walks you through what you're going to be dealing with. You're going to have a contract with this contractor. And you should have a diagram or a survey that details the square feet, the rooms, or sections of the house where the remediation is going to occur. An estimate of how much time it's going to take to complete this, and then an itemized list of materials: lumber, wallboard, carpet, padding, paint, required to do this, so you know how much it's going to cost you. And it will say who's going to provide the renovation materials. Some contractors would prefer to get their own, some of them will let you do it. And then how the contaminated materials are going to be handled. Whether the contractor is going to remove them from the site or whether you're going to have to. And if you're going to have to do it, just remember what you're dealing with. It's not puffed wheat. Be really careful with it. Then detailed warranties of the work, guarantees, cleanup procedures, any products that are going to be used, and then a total price cap. And in extension, we like to tell people to always get at least 3 estimates. Ask for proof of education or training sessions, and then ask to see the license. And you might also want some references from clients, so that you can call people and say, how did this guy work out?
Joe?
Yes.
Well, one of the things that was mentioned at this meeting, Chris and I went to last week, was to make sure also that the contractor has insurance.
Oh, thank you. That's a good point. Mm-hmm.
Okay.
Mm-hmm.
They stress that.
Yeah, workman's
Heavily.
comp and liability.
Mm-hmm.
Yeah.
And more than likely, I think your licensed one will have that.
Yeah, right.
You should still verify anyway.
Right.
So there are a lot of good references online at the EPA website. I'll leave this up so you can write this down. This website has on one side whether you're dealing with it in some kind of institution or whether you're dealing with it in a house, and it'll walk you through what to look for. So here's a response to mold problems. The first thing is to identify the extent of the moisture damage, the extent of the contamination, then the dynamics of the moisture sources. That is, where is the moisture coming from and how is it getting in the house? I should bring this up because we might have to clarify this in New York State at some point, but we used to always say that you've got to have moisture on the site for mold to grow. There is one exception, and there is a mold that grows in California, and its hyphae can extend 30 feet to a source of moisture. So even though there's no moisture, say, on a wooden surface, this mold can actually send that hyphae out. Remember, the hyphae is that thin tube.
Right.
Mm-hmm. And then, how are you going to contain the area where you're cleaning? And I'll show you this in a little more detail on another slide. So in the short term, you have to dry. Get rid of the source of moisture. Dry the place out. And then a long-term intervention is an intervention in the moisture dynamics. And I know that's difficult in the case of a flood, because it could happen again. But you might come with some ideas on protecting your house. And then, how are you going to do the cleanup of the fungal contamination? And then what's the clearance criteria? That means how do you make sure that it's done? Contaminated material gets discarded or decontaminated. And then implement repairs and changes to prevent future problems. So if this is easy in cases where there's been a plumbing leak or a wet basement after a mild rainfall, but with your cases, the case of flooding that you had this year, that's a more difficult issue. I was at a presentation with Claudette Reichel, she's the professor from Louisiana State, and down there they designed a type of house, and it's not wooden studs, they're metal studs, plastic or fiberglass inside the cavity, and you can open up these wall cavities and hose them down after a flood. Yeah, I know, but that's pretty much an extreme step, but they were forced to think outside the box after Katrina, and that's one of the solutions they came up with. This is a moisture meter, and you can see there's mold growing. This is an attic, roof decking, and this has probes. Not all moisture meters have probes, and this shows a moisture content in that wood of 47.9%. Yeah, that's a lot. When wood is first harvested, there can be a moisture content of 200%. And we like to say after a place is dried out, when the wood content is 14, or the moisture content is 14% or less, then it's safe to close things back up. The danger is if you have a higher moisture content than 14% and you close the walls up, you could get mold growing again. This would be another thing to ask a mold mitigation contractor. What kind of moisture meter are you going to use? This shows a fuel oil storage tank in a basement, and you can see mold growing on the section after the yellow line, and before the yellow line, that's it cleaned with a HEPA vacuum. So a HEPA vacuum can do a good cleaning job after something's dried out. Remember, it has to be dried before you use that. So this shows a common place where mold grows in houses, right at the corner where the ceiling meets the wall. And this is typically because some insulation above that ceiling in the attic has been blown away. So there's an exposed cold surface. So with a cold surface, moisture is going to condense on it, and then there's a moisture source for mold to start growing on. And the bottom shows a HEPA vacuum cleaner. So here's someone who's protected with gloves, hopefully wearing goggles and a respirator. The cleaning solution here is dish detergent and hot water, just using a sponge to wipe it up. You can use brushes, rags, a mist spray bottle. Don't use high pressure sprayers. The danger with them is you'll spread mold spores throughout the house. So here for bigger jobs, the must-haves I mentioned, the N95 respirator, eye protection, rubber gloves. Here these guys are wearing coveralls that you take off before you leave the work area and put in a bag. In the bottom we see a dehumidifier that's running while they're working. So this is for containment, and what this slide shows is these are expanding poles that go between the floor and the ceiling, and then this is a plastic covering with a big zipper. So when they go in the area that's going to be clean, they pull that zipper up, and that separates that area from the rest of the house, so that the contamination is not going to spread. There are some code requirements related to moisture, and this is from the International Property Maintenance Code, which New York has adopted. So houses should be graded so that there won't be any accumulation of stagnant water, and that rainwater will run away from the house. There are requirements related to roofing and flashing, roof drainage, gutters, downspouts, and then roof water should be discharged so that it doesn't create a nuisance. Exterior walls are supposed to be free from holes and breaks. All exterior surfaces are supposed to be maintained and in good condition. So if you're renting, your landlord is responsible for this. What I have found, though, in talking with local building officials, is that not all of them are aware of the International Property Maintenance Code and that it has been adopted by New York State. So you might have to point out that this is covered by the code. So exterior wood surfaces have to be protected from decay. And then all siding and masonry joints have to be maintained and watertight. A little bit about moisture in homes, because I find there are a lot of misconceptions people have. How do we get moisture problems? Remember that warm air holds more water vapor than cold air. The cube on the left represents air that at 75 degrees Fahrenheit, 30% relative humidity. That means that it is holding 30% of the water that it's capable of holding. But when that same cube of air cools to 40 degrees Fahrenheit, with that same amount of moisture, that's at 100% relative humidity. The colder air is, the more it condenses, the less it can hold moisture. So moisture condenses at 100% relative humidity. That's called the saturation point or the dew point temperature. This is where we usually see it in our homes in this climate. And I have gotten lots of phone calls over the years in the wintertime where someone says to me, I had new windows installed this past summer and now my windows are leaking. No, they're not leaking. This is just moisture that's in the air of the home, and as air movement occurs, the air gets closer to that cold surface. The air cools down, it loses its ability to hold moisture, and so it condenses on the window. Then what can you do about this? You can either raise the temperature of the condensing surface, and you can do that if it's a bay window, for example. You can put a small fan in there just to keep air circulating, and it won't let the window get that cold. And how does moisture get transferred? How does it move around in houses? Well, air is always moving around inside a house, and typically in a typical house there's a little space around an electric receptacle, but the faceplate hides that. If you take a faceplate off, you might see that. You can put gaskets over those to seal that up. But that's one way that moisture is going to get inside a wall cavity. And if the exterior sheathing is cold enough, the moisture is going to condense on that, and you could get mold growth inside your wall cavity. Moisture can diffuse through gypsum board. That's why we put vapor retarders, plastic sheathing, against the studs before we put the gypsum up. And moisture can move through a concrete foundation through capillary action, much the same way as if you put paper towel in a dish of water, that water is going to travel up the paper towel. That's capillary action. It'll do the same thing with concrete and concrete blocks. So our building codes make sure that our walls are insulated pretty well. But window technology is such that we're still going to have some issues in our climate. What this slide shows is this is just a single pane of glass, a single glazed window, and that has an R value. Remember, R is resistance to heat flow. We buy insulation, we get R16 or R19. But this 8-inch piece of glass just has an R value of 0.0, was that 8 or 6? Sorry. Yeah, 0.06. The interior, and then there are two films of air that hug that glass surface. One on the inside surface of the glass and one on the outside surface. But the overall R value of that single pane of glass is still just 0.91. So it's not very much. And sometimes moisture condensation on a window is just a nuisance. But if it freezes up like this, remember that ice is going to melt. It's going to settle on the window materials and possibly the sill, and then you're going to have mold growth. Recessed windows are a bigger issue. You can have dead air inside that, and when people have big problems with moisture condensation on those windows, I recommend a small fan inside there. Like a computer fan will be big enough. I do I mentioned to you that I'm a former home builder, but I do training programs for home builders as well. And I tell them, avoid putting closets on exterior walls. In our climate, once you close that door, that's a dead air space. That's why people can get mildew growing on fabric, on shoes. So if that's a problem in your house, then keep that closet door open a little bit during the winter, or install louvers in the door. So the conditions for condensation are enough water in the air, the surface is at or below the dew point, enough moisture in the air that it's going to condense on the glass. Yeah.
So you mentioned in the winter, is gas forced air help dry things out?
Yeah, any heating source will. Some people think that if they have a hydronic system, steam heating or a water boiler, that's going to be worse. People also think if you have a wood-burning stove, then that's going to make the house too hot. No, hydronic systems are sealed, so that also will, if you get the house warm enough, that's going to prevent moisture from condensing. Some moisture is beneficial in a house. The key is to maintain a moisture balance. The typical household of 4 produces between 3 and 6 gallons of water per day, just from normal household activities. Cooking, cleaning, pets and plants give off moisture. If you have these ventilation sources in a house, you shouldn't have moisture problems if you're controlling relative humidity. And that is that you are exhausting moisture from every room where it's being produced. That means an exhaust fan vented to the outside in the bathroom. Clothes dryers, for the most part, vented to the outside, but some of the upper scale models now have, this is just with electric dryers, they vent into the washer. And that's for people who put a laundry room on the 2nd floor without access to an exterior wall. But you can't do that with a gas dryer. And then an exhaust fan over the kitchen range that's ducted to the outdoors. Maintenance is also a factor in moisture control. And if you've got a downspout that's falling apart like this, when it rains, what's going to happen? The water's going to run down that siding, then down the foundation, and get into your basement or crawl space. I like to keep my eye out when houses are being built. And I'm not putting the builder at fault for this, but who can see what's wrong with this?
The paper should be on the outside.
Exactly, right.
Yeah.
But these are advertised as self-flanging windows, and some builders think that you just put the felt paper up and then put the window against it. But if it rains, and rain does penetrate siding, it's called wind-driven rain, it's going to run down that felt paper, and as this gentleman pointed out, it's going to get behind the flange, and then it's going to get into the wall cavity and possibly let moisture accumulate. Now this builder's doing it right. Tyvek or house wrap is also used as a rain barrier, but see how he's cut out a flap above the window. He'll put the window in place and then pull that flap down so that it's covering the flange. Think about that with all building materials. Give water a route to escape. Don't let it get trapped inside the house. Here's a house that was built without any drainage plan under the siding. That's just asking for trouble. This is what we deal with in our climate. A lot of groundwater in our basements or crawl spaces. This is an ideal. We don't use the term waterproof foundations anymore. We call them water managed. And with this one, there's a downspout properly installed. The soil is graded, sloped away from the house. There is a treatment against the foundation, some sort of bituminous or silicone coating. And then a board between that and the gravel, and that can also be a drainage board. They have foundation drainage mats now. That if water does get past all these other barriers, the foundation drainage mat will direct the water down to the footing and then to the footing drain. One mistake I've seen a few times is this perimeter drain resting on the footer. This is the correct spot where it should be. This is only a relatively recent recommendation The Department of Energy used to recommend if you finish off your basement, fur it out with 2x4s, put in the insulation, then a vapor retarder, and then you're finished. Drywall or paneling or whatever. But if you look real closely, you can see that water got trapped behind there. What happens on a hot, humid day in the summer, that humid air is going to get into the basement. It'll get into the wall assembly through a crack around that electric receptacle, and then it'll travel through that insulation and get to the foundation, which is cold, and that's where it's going to condense and allow mold to grow. This is the recommendation now. So if you're going to finish off a basement, you first put up a layer of rigid foam insulation. Glue it to the wall. There's a special glue you use when you put up this. This is extruded polystyrene insulation. Some adhesives will eat away at it. So if you're going to do this, make sure you're getting the right adhesive. Then unfaced fiberglass over that, and then you're finished. Notice there's no vapor retarder below grade. So the reason for that foam, that will keep the surface of the foundation wall warm enough so that if moisture does get back into that assembly, it's not going to condense. There's no vapor retarder, so moisture will have an escape route. And dehumidifiers. Yes?
Yeah, in the mitigation they recommending for my crawl space, I have that kind of insulation all around the walls. Because of the flooding in the crawl space, moisture has crept up it, and they're going to cut it out to the 24-inch line. Now, they recommended, because of the possibility of flooding in the future, because flooding may happen there in the future, that I don't replace that.
What do you have, fiberglass?
And I don't know, it is some kind of a hard fiber board insulation
It's fiberboard. You could use expanding foam insulation.
instead of that.
That's polyurethane.
And that would not.
Yeah, that's not going to absorb moisture, and moisture can't penetrate
Is
it.
there any problem though in not replacing it? I mean, I don't use it as a living space.
Well, it'll be colder in your crawl space.
Yeah, they said maybe they could breathe.
Yeah.
So they were recommending I don't replace it.
Yeah, I would do that if I were in your situation, or I would use expanding polyurethane insulation if you want it to be
If I wanted
insulated.
to do it again.
Yeah.
Well, one of the problems that I've run into with this very similar situation is as long as the insulation is up against the wall, the moisture that was caused by the groundwater, the concrete block walls are still wet, and that's what's.
Yeah. And that's if you're using fiberglass insulation and you don't have a system like this. Yeah, the concrete block will stay wet.
Yeah, what I have is basically what all the builders are using today.
Fiberglass.
Yeah.
Yeah. Yeah. Well, I have noticed when I have used this slide when I teach builders, this is new information for a lot of them.
Yeah, they just been slapping, meeting the code with just a basic
Now,
installation.
I am leaving this slide presentation with Mary. You might want to get in touch with her and get this slide to show
I'm
about
just
it. Oh, you're ripping it off.
Installation out.
Uh-huh. Uh-huh. And do you have a concrete block foundation?
Yeah.
Yeah, so you might want to do this.
Well, the insulation in my house is just going to disappear.
Is it?
I don't care if the crawl space is a degree or two colder.
Yeah, that's understandable. Basements in our climate do need dehumidifiers. So I have a full basement in my house. This is from my basement. Before I knew this stuff, I used to open the windows every summer to air out the basement. No, don't do that, because that's just going to bring humid air in. It's going to condense. I don't have a basement floor drain, so I put together this assembly, and it's just wood steel straps attached to 2x4s. I attach to the joists, and I have a tube that runs into the utility sink, so I don't have to empty the pan. If anyone wants specifications on this, get in touch with me. Mary knows how, and I'll send the specifications to you.
For the crawl spaces, mine has 4 vents, and I open them up in the summer, close them in the winter. Is that not right?
No.
Keep them closed?
No, it's still in the code that you can do that. This is how we typically used to build crawl spaces. Dirt floors, vent, which is prescribed by the code. What happens though in the summer, when that warm, humid air gets into the crawl space, it's going to hit the earth-cooled foundation wall and it's going to condense. So you can go to a website of the Building Science Corporation. Just Google Building Science Corporation. I think it's bsc.org or .com, but they have good publications on crawl spaces. This is what's recommended now, is that you put a vapor retarder on the floor and then all the way up the walls, and then it's sealed. Any overlapping seams are sealed with caulking compound to make sure it's dry. And there's no venting in here. What's recommended now is that you condition this crawl space so that when you're heating your house, you have a vent that opens into the crawl space and keeps that crawl space heated. And you're not going to have any moisture problems. Same thing in the summertime with air conditioning. If you air condition your home. This, I don't know, maybe tell me from your experience, but from what I've seen, this is the exception, not the norm. Anyone have a crawl space like this? You do, good. Oh, today? Good for you.
Actually, I found out at Sodus Point, you don't want a crawl space.
Yeah.
Or a basement.
Yeah, probably want a house on piers.
Well, slab at least,
Yeah,
but unfortunately, we built our house 3 years ago.
yeah. I have a shed that's attached to my house, and that has a crawl space, and I don't like that.
Exactly.
Yeah.
What happens if the surf, or the water level rises and you have something down there?
That's a really good question. Well, ideally, you could have a cement floor, but that's going to be pretty expensive. I wonder if you weight it down enough with concrete blocks, whether that'll keep.
What is that? What is the material there?
That's high density polyethylene.
High density polyethylene. Will that float?
Yeah, well.
So
Yeah, in a case of a flood, I think you're right, where the water is going to be up there 3 or 4
so the
feet.
concrete would be the best.
Yeah, yeah. But even then,
even with the concrete, because I have concrete,
Yeah.
once the water table gets to a certain level, and once the water comes up around your foundation where the flood windows are, just pours
It's
right
gonna
in.
go in.
And like we had problems with
With
silt
the-
flooding up the outtake for the sumps, and then everything just backed right up. So, you just fix it after the water
Yeah.
goes away.
It said close the window, seal off the windows now.
Yeah, you could do that. I'm not sure if the groundwater doesn't come up.
Still.
It does.
Still.
Ours comes up to the floor, cement floor,
Yeah.
and at 5 months of that, as soon as you leave the windows open,
yeah. Oh, in that case, sure, you have to. You might even want a dehumidifier or two in
well,
there.
we're afraid of electric.
Right, I took the humidifier out when the floodwater started because you don't want it sitting there.
Yeah,
And what happens is it gets so humid in the basement that even though it doesn't get near the wooden underpinnings for the floor above, it's just dripping water off them because of the condensation.
yeah,
So there you
yeah.
are.
I think this gentleman was right. You don't want crawl spaces up here.
Can there be mold inside the cement blocks now when it's sitting in the water?
If they have a nutrient source, yeah. If they don't, no, there wouldn't be a nutrient for mold in there. But if something gets in there,
Because if it's
dirt,
stored-
and then you don't know what's in the dirt, that could happen.
Because
So
there's
what?
a lot of silt.
Yes, lots of
I mean,
it.
it's just everywhere where the
Yeah.
water's been.
So you could get mold growing on that.
A third of ours is concrete, the rest of it is dirt.
Uh-huh.
And I've been using a fan every day to dry that.
Is it working?
I don't know, because I haven't crawled back in far enough to find out. I just had search on my
Oh,
hands.
good luck.
But I plan on it.
Gee, there you gotta get more familiar with your crawler.
Yes.
In our neighborhood, we're built on the sand.
Uh-huh.
We have a crawl space that's about that tall
Uh-huh.
on a slab. But seasonal changes happen to the house. It shifts.
Mm-hmm.
Crawl space, the slab has got cracks in it.
Mm-hmm.
And so, as the water rose, it came up to wherever the water is in the bay, that's where it is pretty much underneath our house. As the water rose in the spring, it came right up into the basement through cracks in the slab, and there was cracks along where the slab meets the
Yeah.
cinder blocks.
Yeah.
And they're all wet.
So we would have 4 pumps running just to
Wow.
keep the water out as it came in.
Yeah.
Now, for the last month, we've been trying to dry everything. I got everything out of there, trying to dry everything out.
Yeah.
But if there's another flood, the same thing's going to happen. I mean, what's the best kind of sealant for a slab under those circumstances?
Polyurethane caulk.
Polyurethane caulk?
Yeah, it's black. That adheres well to concrete, and water can't penetrate that.
And seal the whole floor with it?
Well,
No, cracks in the concrete.
Okay.
Yeah.
What about where the slab meets the cinder blocks?
Polyurethane caulk.
Okay, thank you.
But then the wall is all wet with rocks.
Yeah, wait till it's dry before you do that. Yeah, this'll provide one root of protection, but again, when you get a big flood like this, water is pretty good at finding its way in.
The worst part about this whole deal is it is going to happen again.
Yeah.
Yeah.
If we don't, unless we get rid of the plan in 2014. But it's just when the shoe's going to drop, the other shoe.
Yeah, well,
So,
where is Marty? There's a meeting next Friday
yeah,
about that?
we're going to it, yeah.
Okay. I mean Chris, sorry. Just a little bit more about this, even though it's not relative to flooding, it is relative in our climate. Ice dams are a problem. And people used to think that ice dams were caused by inadequate attic ventilation. What it really is there are holes in an attic floor for electric wires, plumbing pipes, and they're usually not sealed, and that allows warmer air from in the house to get into the attic, and then it rises to the underside of the roof decking and melts the snow. And then that's what causes the melted snow runs down the roof, gets over the overhang, which is not heated, and that's where it freezes and causes an ice dam. And this shows how air moves through a house. Remember, people often make the mistake to say that heat rises. You can always correct that. Heat's a state of energy, it radiates in all directions, but warm air rises. And see how it does, it goes up into the house, and then it'll get up into the attic. So when I teach builders, I say, when you are doing, installing electric wires, use expanding foam around the penetrations. Same thing with plumbing pipes, and that'll prevent any of that warm air from getting up into the attic. This is from my colleague's house, Mark Pierce in Ithaca. He bought an old house, and there's the plumbing drain waste vent stack with 2 armored cables. Look how big that opening is there. Look how big that hole is there. So what he did, he hired his nephews to get out all the old cellulose insulation that he had in his attic, and then he had contractors put a layer of polyurethane foam. And this is real good at sealing all those holes. And then he put fiberglass insulation on top of that. So he doesn't have ice dams anymore. If you had cellulose insulation installed, sometimes it settles, and that puts a cold spot in the wall. The picture on the right shows that someone put fiberglass insulation too far into the eave, and so when water comes up through the soffit vent, or air comes up through the soffit vent, it can push the insulation out of the way. So we recommend these. These are attic vent or rafter vents. Put those, and you've got a path for air to go from the soffit vent to the ridge vent, and then your insulation can't get out into the eave. So what is a healthy level of moisture in your house? It's measured by relative humidity. What this slide shows that, we'll start, the bottom axis shows levels of relative humidity. From 0, the last line is 100, it should be there, but it's not. So there are bacteria at low and high levels of relative humidity. Viruses, same thing. Fungi, dust mites, they can't live without moisture, so they're at the higher levels of relative humidity. Allergic dermatitis, asthma, that occurs at low and high levels because of the pollutants above them. Respiratory infections, there weren't enough data from this particular study to look at high levels of relative humidity, but you get respiratory infections at low levels because our mucous membranes dry out and crack, and then we get pollutants in them. Chemical interactions, this is formaldehyde off-gassing, and this increases as relative humidity increases. Ozone production from some faulty appliances, more at the low levels. The point of this slide is that even though these pollutants exist at low and high levels of relative humidity, there's an optimum zone of between 35% and 55% that's considered to be a healthy level of humidity in a house. So in my house, I have a couple of the digital hygrometers that measure relative humidity, and I just keep my eye on them in the wintertime. So I often get the comment, why don't we build houses like we used to? We didn't have these problems until we tightened them up. But we were relying on accidental ventilation through building cracks, and there's no control, and that's affected by wind speed, topography, vegetation around the site. It's better to have an airtight house where ventilation can be controlled. These are from my house. There's a exhaust fan over the range, ducted to the outside. That's the roof of the exhaust fan on the right. Exhaust fan in the bathroom, ducted to the outdoors, and my dryer is vented to the outdoors. Some very tight houses, exhaust fans aren't going to get enough makeup air to function properly. So Lawrence Berkeley Lab did a study, and they recommended if you have an air change rate of below 0.35 or 0.35 air changes per hour, install these makeup air inlets. They get installed in the upper ends of a wall, typically in the living room or bedrooms. And when an exhaust fan comes on, they sense the negative pressure and they open up a little bit to let some fresh air into the house. Or at the high end, you can use an air-to-air heat exchanger. These exhaust stale air from inside the home, bring in fresh air, and the drawing on the top shows that there are conductive plates that extract the heat from the outgoing air, transfer it to the incoming air, so you get fresh air without the energy penalty.